right, geometry, section 1.2 is measuring segments. So a rule that is accepted without proof is called a postulate. So remember, I told you yesterday, when I have something bold and italic, that usually means on my notes that is a definition that you'll probably need to remember. So we have one right there, and then our next one would be a rule that can be proved is called a theorem. So it's just like how we started yesterday with point, line, and plane. You have to start with postulates, so you can use a postulate, something that's assumed to be true, so that we can prove theorems, which we need to prove, all right? So we'll see that later on as we keep going here. So the first postulate that I'm going to give you is called the Ruler Postulate, which states points on a line can be matched one-to-one with real numbers. The real number that corresponds to a point is called the coordinate of the point. So if it's just a straight line like this one here is, there's just an x value, and remember, if we have the coordinate plane where we have one going up and we have one going over, so that's our xy, it's going to be an ordered pair point. It'll be x1, y1, which we'll get to later on in this segment here. So the distance between the A and B is written as AB. So notice there, ladies and gentlemen, on that one there, there's no arrow above it. There's no ray. There's no line segment. So when I have nothing above it, then we're just talking about the distance, all right? And the distance between A and B is the absolute value of the difference of the coordinates. So example 1 here, measure the length of AB to the nearest tenth of a centimeter. So on here, I'll tell you, I went ahead and made I measured it here. And again, you don't have to always start at 0. I actually started at 2. And then when I put my ruler on it, I found that this here was 4.2. And that was in centimeters, all right? So again, using our formula here, I have to call one of them x1, one of them x2, excuse me. And then according to our formula, we know that AB, again, since I don't have anything over it, that means that I'm doing the distance, which means I'm going to take the absolute value of x2 minus x1. And in this case, I have 4.2 minus 2, which would give us 2.2. Remember, if it was a negative, the absolute value makes that negative a positive. And I just told you it was in centimeters. So remember to use your length. If they don't give it to you, you have to put it in there, or they will mark it wrong. Okay? Line segments that have the same length are congruent. The symbol, well, this symbol looks like an equal sign with a squiggle over it. That means congruent too. So we can also tell that they are congruent by tick marks. So this right here in between the A and B is a tick mark. And just remember, tick marks show congruence. All right? So when line segments are equal, that means that they have the same length, and then the segments. So notice the difference here. Right here, we're saying AB, the length of AB, the distance from A to B is the same as the distance from C to D. And if they're the same length, then we can say that they are congruent. So now here again, I'm putting up the line segments there because that's what I had there. And I'm just telling you that they are congruent. All right. So example 2, plot the points P of is -4 and 3, Q is 3 and 3, R is -1 and 4, and S is -1 and 2 in a coordinate plane. Then we're going to determine whether PQ and RS are congruent. So first thing we have to do is we need to plot the points. So remember, the first point is going to be in the x direction. So on P, I'm going to go over -4. So 1, 2, 3, 4. And then I'm going to go up +3, 1, 2, 3. And we're going to label that. Remember, it's a capital letter, so I'm going to label it with a P. The Q then is 3 and 3, so 1, 2, 3 in the x direction, up 1, 2, 3. So there is point Q. And let's go ahead and just go and plot all of them. And then let's see here. My next one is R is at -1 and up 4, 1, 2, 3, 4. And that is our R. And then our S is -1 and -2. And there's our S. So again, what they want us to do is we want to determine if they are congruent. If they are congruent, then we know that their length, that length there, has to be the same as this length here. So let's go ahead and do PQ. So our PQ here, remember this was -4 and 3. This one here was 3 and 3. So in this case here, what you are going to look at is you're going to look at, in that case, it's the x direction, because that's the only one that changes. So we're going to say that PQ is equal to, and again, let's call this one here X, what did I call it? X1. This one here is X2. Again, notice that the Y's stayed the same, so the only distance is going to be in the x direction. So we're going to again call that x2 minus x1. And in here it's going to tell us it's, let's see, x2 is 3 minus a -4. All right, so again, I'm going to have that right there is a negative times a negative, which becomes a positive. So that tells us we're going to have it equal to 3 plus 4. And that will give us 7. For RS, all right, so if I do RS, let's see, I'm going to have our R point was -1 and 4. Our S point was -1 and -2. So on that one there, which ones are the ones that stayed the same? So it looks like on here it's our hex has stayed the same. So we're going to say then that it has to be the y direction. So y2 minus y1. And again, let's just go ahead and label them. So I'm going to label this one here as my y2. And this here would be my y1. So according to what I have, I'm going to have -2 minus 4, which is the absolute value of -6. And again, since it's -6, the absolute value makes it positive. So our distance for PQ is equal to 7. Our distance from RS is equal to 6. So we know that 7 does not equal 6. So we can state that line segment PQ is not congruent. So again, to show it's not, I'm going to put a line through it. It is not congruent to line segment RS. All right, our next one, we've seen the segment addition postulate before. It says if B is between A and C, then we can say that the distance from AB to BC, so if we add those together, it's the same as the total length AC. All right, and then they're also saying if the opposite of that is if I start with if AB plus AC, so if I'm talking about that, is equal to AC, then we know that B is between A and C. All right? So they're just kind of telling you the statement and then the converse of the statement, and we're going to learn what those words mean later on too. So example 3 here, it says find the distance or the length for xz. So on this one right here, according to what they just told us, xz is the total, and we know it's going to equal the parts, so it's going to equal xy plus yz. In this case, our xy is equal to 14, our yz is equal to 27, so we can state that the distance of xz, which was what we did not know, is going to equal 41. Right? That would be 41 units. They haven't really told us what that whole thing is. Now, sometimes you're going to have to find the part, all right? And you know the whole on this one here. So again, on this one here, we know that the whole part is BD, all right? But we know that it equals BC plus CD, all right? So if we look at that, let's just fill in the blanks here. Let's see, BD is the whole length is 25. BC we know is 19. And then we have CD. So CD is like our variable, all right, which we kind of just did the other day. How do I get CD by itself? Well, you're going to subtract 19 on both sides. And that will give you the length of CD. So now you'll be able to tell me that CD is equal to, well, 25 minus 19 is 6. And then finally, our last one here is if the cities shown on the map lie approximately in a straight line, find the distance between Sacramento, California to San Bernardino, California. So let's see, Sacramento, why don't we call that, let's say, how about S, all right? Fresno's in between them, and let's see, S, San Bernardino. Well, I can't call that an S either, can I? Because I already used the S for Sacramento, so let's call it SB. All right, so if I think about that, I can state, so first thing I did was I labeled the points. So I can say that S, F, let me see. I think I'm going to do this different. Yeah. So let me go ahead and do this different. So I'm going to call, and it'll make more sense here. So let's call San Bernardino, let's just call that B. That sounds a lot better. So let's just call it B. All right. So then I can state that my distance from Sacramento to Fresno, which I'm going to call SF, all right, is plus my distance from Fresno to San Bernardino, so that would be FB, is equal to the total length. So the total length there is right there, okay? And that would be from Sacramento to San Bernardino, so SB. All right, when I plug that in, from Sacramento to Fresno is 158 miles per hour. 158 miles, excuse me. And then we have from Fresno to San Bernardino is 230 miles. And if we add those all up, we'll see that equals SB. So SB then would be, so from Sacramento to San Bernardino, we would say that is 388 miles. Again, use your thing if you can. Use the units. they'll get you on that every once in a while. That's it. Thank you.